Good afternoon, good day, everybody. My name is Jim Pippin. I'm the chairman of the local APM branch here in Hong Kong, and this is our very last webinar of the year. Thank you for joining us. Today, Mr. Mark Lomas, who is the project director for the Peak Tram upgrade project, will be giving us an overview of this very important project and historic project here in Hong Kong. Mark has led numerous large collaborative design and construction teams on various complex major infrastructure projects across Hong Kong over the past 27 years. Mark's also the former chairman of the APM Hong Kong branch and a proud recipient of the APM Chartered Project Professional designation, having previously championed its predecessor, the RPP, for project professionals based outside of Hong Kong, outside of the UK. So, Mark, welcome, and we're very much looking forward to your presentation today.
Thank you, Jim. I'll turn the camera off and just go straight into the presentation. Hello, everybody. Good morning, good evening, wherever you are. Thanks for joining. I'm going to talk for maybe 30 minutes or so. And then give you guys plenty of time for questions and answers afterwards. Hopefully at the moment everyone can see the screen okay. Slide 2 is just a brief introduction. Jim's given you a brief introduction of who I am and how I got here. And just before we started, I was talking to Rob from APM. And when I came out to Hong Kong, it was with no particular end date in mind. It was just because construction in the UK in the early 90s was a little, shall we say, dull. And what I wanted was some more interesting and substantial projects. And I've certainly had that over the last 27 years, working on airports, hospitals, railways, you name it. And my last project before the one I'm going to talk to you about tonight was high-speed rail. And the extension of China's high-speed rail network down into Hong Kong. And I went straight from high-speed rail to what we're going to talk about tonight, which is very low-speed rail. So bear with me, and I will begin. What I'm going to talk about very quickly is the history of the Peak Tram, which Jim alluded to, and then try and describe how the existing funicular system works. I will talk about the project work that we're currently doing, and then hopefully some questions and answers. So the Peak Tram actually opened in 1888. And the reason the Peak Tram was built in the first place was, at the time, the Peak of Hong Kong was fairly sparsely habitated. And the only way up to the Peak was via sedan chair. And in order to populate and live on the Peak, it was felt that a direct mode of transport was necessary. And in the 1880s, an enterprising Scotsman called Alexander Finlay Smith made an application to government to put a funicular railway up to the Peak, began construction, I believe, about 1885, and opened by the governor of Hong Kong then in 1888. And over the years, we've kind of transformed from an essential mode of transport to what is now a world-renowned recreational facility for tourists, and in different times, Hong Kong's #1 tourist attraction. Over those years, and this is quite an interesting thing, over those years, over 130 years, we've only had 5 different types of tramcar because they are quite well built to last. And we started in 1888 with a fully wooden tramcar and with coal-fired steam boilers at the top. If you look to the bottom right, you can see the old boiler house at the back of the tram. And in 1926, that was replaced by an electrically powered haulage gear system, and we upped the capacity of the cars from 30 to 52. In 1948, it was changed again to an all-metal tramcar and upped again to 62 passengers. And the one thing that I don't know and cannot find from our archives is why that 1948 tramcar was replaced so quickly in 1959 by the all-aluminium tramcar, which then held 72 passengers. Now, we still have two of those 1959 tram cars. One is parked on a siding on the tramway, and one is actually being donated to the Hong Kong Tourism Board and is a tourist information centre on the Peak. And then in 1989, we retired the 1959 fourth generation, and the new ones were then articulated two-compartment tram cars, and they were then also computer-controlled systems and carried 120 passengers. What we are running is a two-car double reversible funicular. Its speed is a maximum 6 meters per second. We could run faster. There are regulations in Hong Kong that limit the speed. We could run faster. I've been on ones in Switzerland that will run up to 10 meters per second. Our track length is just over 1.3 kilometers, and it climbs to about 396 meters above sea level once you get to the peak. The drive station, all the mechanics are in the top at the Peak Tower, and as said, it was manufactured, installed in 1989. The capacity is 120 plus one, the one being the operator of the cab. And the maximum slope of the track as we get to May Road Station is 25.7 degrees. And that's very interesting if you've ever tried to get on or off a train when the train's at 25.7 degrees, but the ground you get off on is flat. So that's quite an interesting demounting point. The route of the Peak Tram has stayed pretty much the same over those years, running from St. John's Building. And if you look up in the top left, the original Lower Terminus was then redeveloped in 1935 to those lovely old colonial flats, the St. John's Apartments. That was knocked down in 64, and in 1982, the new 14-story St. John's Building was constructed. And whilst that may look like an office block, they were in fact quite luxurious apartments for the time. And that was taken down in 1983, and the current 22-story St. John's Building was constructed. We were then run through the 4 intermediate stations at Kennedy, McDonald, May, and Barker Road. And at the top, on the top right, you can see the new Peak Tower. For those in the Hong Kong audience that know Hong Kong history, the 1972 to 1997 old Peak Tower was quite an attraction. And then there's an old picture of the original upper terminus in the bottom right. We operate 2 tram cars. As I say, it's a double reversible funicular system, and I'll explain how that works in a little while. They are, shall we say, interestingly called the white car and the green car. For those of you that can read the Chinese, on the left is the green car, the green dragon, which is to do with the sea, and on the right is the white car, the hillside car, which is to do with the tiger. And here is some of the 1989 modernization. We have a documentary from the 1989 renovation, and it's quite fascinating, and you'll see in this little clip that's running, hopefully running okay for you bottom left, the complexity of that PLC logic controlled system for computer controlling the equipment, and the old teletext type printers. But in 1989, that was state of the art. How does it work? We basically get 380 volts AC from the local electricity supply company, not yours, Jim, it's the one on the island, I'm afraid. That runs into an AC motor through a DC generator into a DC motor, and we apply the control system at and on the DC motor. DC motor then goes through the gearbox to drive the haulage drum, and a lot of our instrumentation is then positioned on the haulage drum. Bit by bit, here's the power coming in. Here's a very old AC motor into a DC generator, through floor trenches, across to the DC motor, across to the gearbox, and across to the haulage drum. And just at the foreground of the picture, you can see the hydraulic system, which then feeds the brakes. And on the existing winch, we had a pair of brakes, 2 emergency brakes and 2 service brakes. We had 2 ropes wound on the drum, each length just over 1.5 kilometers and a diameter of 44 millimeters. So they're quite substantial ropes. Again, there they are, the white and the green car. And then we have 1 winch, but 2 deflection sheaves. And as you can see, what happens is when the winch turns, 1 rope is winding in and 1 rope is winding out, which is why the 2 tram cars then can run in opposite directions as a counterbalance to each other, if you were. The track itself, as said, it's about 1.3 kilometers long. And this is how it works, because on a double reversible funicular with a passing loop, we actually do not have any points. We used to have some points on there to get into a railway siding, but we don't need any points because on each car, and there are only 2 cars, there's a set of flanged wheels and a set of flat wheels. And the flanged wheels make the cars run on the outside rail, depending on which one it is. You can see on the left there is a flanged wheel, which hugs the railhead, and a flat wheel, which slides across and allows the tram cars to run over the crossovers. And there you get a graphic of the flanged wheel over the outside rail and the flat wheel running across the crossovers. So why am I here? What are we doing? The challenge as we had it was an increasing patronage. As I said, we became an essential tourism attraction, and as we got up towards sort of 4.5 million passengers, we had a bit of a dip in '97 near to the handover. We had a big dip in 2002 when SARS hit. But since around '97, we've been tracking passenger demographics and looking at the increase in passenger numbers for each of those demographics. I think the peak was in 2016, where we served over 6 million passengers in the year. And the interesting growth on this graph is that the so-called foreign individual tourists make up the majority of that, which is the green shaded area. But the grey shaded area is tour groups. And there was an ever increasing number of passengers as part of tour groups. And that's important for us as an operator, because we have to understand our business model and our demographics. And then we have to cater our offering accordingly to make sure that our different classes of passenger are all happy with the offering. The difficulty for us was when we were pulling 6 million passengers a year, it got very busy, and in particular at the Lower Terminus, which is where most people would catch the tram from, there were some horrendous queues which wrapped all the way around the building and out onto the street, because inside the building, when it was first developed, we only had space for about 420 passengers to wait. We could quite often have 2,000 passengers in the queue. To improve matters, what we tried to do was we housed some of those waiting passengers. We borrowed a bit of land across the road under the flyover, so at least they were protected from the sun and the rain, and that helped us to stack up another 450 people. Excuse me. But as you can see, during the busy times, queues formed up quite quickly, both at the upper and lower terminuses. But the queue times sometimes at the Lower Terminus were over 2 hours, and that was intolerable. So we needed to do something. We needed to do a capacity upgrade. Now, because of some of the existing infrastructure that we run under along the tramway, we run under several road bridges. We can't make the tram cars any wider, and we can't make the tram cars any longer. Right? I mean, any higher. The only thing we can do is make them longer, and that is indeed what we've done. So the current tram car shown bottom right is around 18.7 meters long, carries 120 passengers. The proposed tram car is just over 33 meters long, carrying 210 passengers. And what we had to do was actually move the platforms from the existing platform area, which is here, attached to the St. John's building here, and move it up the hill by about 75 meters. And what that allowed us to do was, first of all, get this very long articulated tramcar into the platforms. It wouldn't have been able to turn the corner into the old building. And it also then creates a lot of space downhill of the new platforms, so we can create a new terminus to house people who need to wait. And that is why we came up with the Peak Tram upgrade project. A quick comparison of the main technical headlines here, and the ones worth noting is the length. We've shortened it by, let's say, 75 or 80 meters. The capacity goes up from 900 to 1575 passengers per hour per direction. The haul rope diameter goes up from 44 to 50.5 millimeters, which is quite a substantial haul rope. And clearly then our peak motor power goes up quite substantially as well. To allow us to do that, we have to change the rails and the ropes. We have to do significant foundation and bridge strengthening to take the extra weight. We've actually had to demolish and remove and reinstall brand new haulage equipment at the upper terminus. We need a new, bigger winch, a bigger gearbox, bigger motors, bigger electrical and control cabinets, deflection sheaves, and an item called a rope length compensation device. Here's a comparison on the tram cars. And as you can see, the increase in length there and the additional number of seats that we've managed to install. I'm not showing you the color of the tram cars because that's not available yet. So this is what the lower terminus will look like zone by zone. Arrivals, we're trying to create more of a sense of arrival and more of a landmark arrival space. We've then got an awful lot more space for ticketing and queuing. We then have a waiting area 1, which is directly after the ticket gates before people get on the travelators. Because of the slope of the site, we've had to install a pair of travelators at 12 degrees to get people up the hill, into the waiting area 2, and then finally onto the platform. This is what the Peak Tram main entrance used to look like, and I would defy any of you who haven't been to the Peak Tram to actually find from this photo where the entrance is. And that was one of our problems, is that people really didn't know where the entrance was. So that fountain will be removed. Here's an architect's early rendering of that fountain removed and the hillside cut back to create a more open entrance, if you like. Hopefully some of these videos won't be too laggy when we play them. But what we ended up doing was a sightline study. We had a study of all our traffic routes in and all our percentages of different demographics coming in from different positions to make sure that everybody could see the new open entrance from each of those incoming points. And then we created this big open space. And within the water pond, we have a significant piece of public artwork, which is actually just being boxed up and put in a container to come to Hong Kong so we can install it fairly soon. And this is the later artist's impression of what it was going to look like. We're also then obviously going to fully gut refurbish the interiors, lots more queuing space. We've got quite a bit of old haulage gear to display in there. So we've made the most of a lot of our historical artifacts. We've increased the number of ticket counters because if we're carrying more passengers, we need to be able to sell more tickets to get people through the ticket gates. So that is not then becoming a bottleneck in the system. And then in the waiting area 1, which is part of the batching process, there will be an AV installation with a show just to keep people interested and happy during the period that they're waiting. And this is a view up the track. The lower terminus is in the building directly below us. And as you can see, it's a very, very narrow site. And on the right-hand side is a declared monument. And on the left-hand side is another declared monument. which means that the Antiquities and Monuments Office were very keen to know what we were going to do and how we were going to manage it and protect these old and historically preserved buildings. Because what we wanted to do was put a glass and steel enclosure over the travelators so that we could get our passengers up the hill in relative comfort. That's the pair of travelators, as said, that are going to climb their way up the hill and eventually up to the platform there. The platform itself is open air because it's part of the transition from the air-conditioned environment in the ticket space through a mechanically ventilated transit area through an open and naturally ventilated platform. We were also, shall I say, obliged to upgrade some of the surrounding infrastructure. So all our passengers will now discharge onto Tramway Path, which is part of one of the main nature walks in Hong Kong. So we'll be upgrading all the finishes down Tramway Path. And what we've had to contend with in most of this is a very, very tight site with very little site area for laydown, storage, contractors, sheds, etc., which presented quite a lot of challenges all the way through the project. We went and did a point cloud survey very early on to produce a BIM model so we could understand what the surroundings looked like and that we could model the new space within that and maximize the volumes and the areas that we were able to build, and that proved to be very useful. I think unfortunately for us, the consultant team didn't follow through with the BIM modeling into the design, which I would have preferred them to do. But certainly the point cloud and the BIM modeling of the existing infrastructure was a worthwhile investment. As I say, here's the Lower Terminus, arrival, ticketing, waiting, travelators and waiting area 2. And to enable us to do this and to enable us to discharge passengers correctly at the Lower Terminus, we had to go to government for 3 really thin slivers of land. The one on the left-hand side here, we needed a thin sliver of government land for the extension of the passing loop. As there are 2 cars on the same track, if you move the bottom point upwards by 80 meters, you're clearly moving the passing point up by 40 meters. So we had to take a thin sliver of land about 2.5 meters wide and 45 meters long, so we could build track bed and lay new track on the extended passing loop. And at the Lower Terminus, we needed 2 additional areas of land. I'm going to skip through this video, forgive me. We needed 2 additional areas of land. The yellow one was a bit of dead space between the tramway area, landlocked between the tramway area and the adjacent lot, which is the Helena May Institute. So we applied and successfully got that portion of land. And the blue area is the area between the existing tramway and tramway path. Again, it was government land, it was unused, it was unallocated, and it was quite useless. And we applied for that. And that took a little bit of getting, but what it also did was it gave us 7 trees to look after, which we never had before. But what it allows us to do then is to move the platforms uphill, which is to the bottom left of the picture. And that then allowed us to create this huge construction site in which we could then build the new Lower Terminus. We did a lot of passenger flow modeling so we could make sure our batching worked. And you can see here, batching people through the queue system into waiting area 1, then they are then released up the travelators into waiting area 2. People board, people discharge, people then get onto the platform. And we try and batch people through in sequences of 8 minutes at busy times with our 210 passengers every 8 minutes. We also did some passenger flow modeling on the pinch points, if you like, in waiting area 1, which is a holding area, and on the travelators themselves, just to take a look at what our level of service was Amazing that in passenger flow, we still look to that 1960s text by Fruin on levels of surface and service and passenger flow modeling. Even using computer techniques like this, we still refer back to Fruin. To enable us to do this, what we had to do was put in place a temporary service plan, because whilst we were doing the construction, the tramcar was still operating. So anybody arriving at the lower terminus at the old fountain area would be escorted across the road and into a queue depending on their particular demographic. They either had tickets or they were there as part of a combination package with some other attractions, or they were part of a tour group. And what we did was we batched them into those queues, and then we batched them into this single queue here where they were all ticket holders, and then onto the platform and onto the tram. And here's a view of our ticketing, our temporary service plan queue running up Tramway Path, and the giant hoardings that we put around the construction site. And here's the temporary platform itself that we build. We just laid concrete either side of the existing tracks, put hoardings up to protect the passengers from the surrounding areas, and we ran off this temporary platform for quite a while. The upgrade benefits and the ones that we were working on as both as a business case and as a justification to government, the key one obviously was a capacity increase of 75% and to reduce waiting times by over 80% and completely remove the queues from outside the two terminus buildings. Importantly also, we improved Peak Tram access for disabled passengers. The old Peak Trams that had just retired had 2 steps into the trams from the platform. So getting a wheelchair on and off was quite a, shall we say, a difficult process and not at all convenient for a wheelchair passenger. And obviously we want to provide covered, air-conditioned, comfortable waiting for up to 1,300 people. Some of the improvements for passengers with a disability, the new tram cars are now level with the platform, so there are wider doors, allow roll on, roll off. It's all 8 doors with wheelchair fixings at each gangway. There's a wheelchair lifting platform to be installed. We're making sure that we have step-free access from the disabled parking in Tramway Lane all the way up to the platform. And also, if required, if anybody wants to, you can arrive at the main entrance in the lower terminus and make your way all the way through to the platform, again, step-free. In the haulage room, obviously, we've got a lot of new equipment to install, new winch, new gearbox, etc. Because of the size of it, we now have 4 emergency brakes and 4 service brakes on this increased winch drum. We have 2 motors running in line, running into the gearbox, and the joy of that is if one of the motors crashes out during the day, we can put it into free running mode and run on one motor, albeit at a reduced speed, and then overnight we can swap out the motor for the spare that sits alongside them in the haulage room. We've had our tram cars designed and built bespoke in Switzerland by a manufacturer of tram cars and gondolas and aerial tramways, etc. And I must say that was one of the most enjoyable parts of the job. To be able to design a vehicle from scratch in that way was quite rewarding. And here's a picture of the guys doing a pre-assembly of the haulage winch drum in the factory in Garaventa in Switzerland, just to make sure that it can all be assembled as intended. And then they knock it down, pack it into crates, ship it on a barge down the Rhine, and then on a cargo vessel out to us here in Hong Kong. On the left here, we have the gearbox, imported from Sweden. The gearbox weighs 17 tons. It was extremely difficult to get that gearbox into an underground haulage room through a tiny hole in the platform floor, but we managed it by tipping it on its end and then turning it round inside the haulage room. And on the right, an awful lot of new control and power panels. The companies that we've used, and there aren't many companies in the world that can do funicular projects, in particular Garaventa, part of the Doppelmayr group, have been very good so far. So that's a little bit of, what should we say, that's a little bit of history and technical information, and project scope information, which might be very interesting, but you're all sat there by now saying, well, what about the project management? So because this is the APM and we are talking about project management, I just want to spend a few minutes talking about some of the aspects of project management of this small but extremely complex endeavor. And the first one that I want to talk about is the stakeholders. Now, on a project like this, we do have a lot of stakeholders, and we ran a very comprehensive stakeholder management study and plan. Not only for the two declared monuments either side of us at the Helen and May, but also all the way along the tramway, and also some of the political stakeholders as well, which I'll show you in a second. For Helen and May in particular, they are a charity, and they have living accommodation within the premises, and one of their biggest concerns was the new platforms and the visual and noise intrusion that they may cause on their garden, which they get a lot of use and pleasure out of. So as part of our being a good neighbour, shall we say, we completely redesigned and rebuilt their garden with a hedge there, which will shield them from all of our construction and the eventual lower terminus when it's completed. And in the bottom right, you can see a very delighted chairman, third from left. That's our chairman. Jim, that's your chairman as well. Just opening the ribbon when we'd finished with the Helen and May garden. I mentioned some of the political stakeholders. We had to do a lot of canvassing to get support from all parties for this project. In 2015, there's my boss, top left, giving a presentation to Legislative Council members. That's Hong Kong's Parliament, for want of a better term. And then there's a few of me in 2018 presenting to the District Council members. It was very important for us to get stakeholder buy-in from District Council for things like the land acquisition, but also for the traffic impacts that the construction and the final terminus, when finished, will put onto the traffic systems at the top and bottom stations. And bottom left is LegCo panel on economic development. We had to go into LegCo and answer some questions and make a presentation to LegCo so that they would pass any legislation that was necessary for us to continue with the project. Now, for those of you who don't know or might not remember, in Hong Kong, projects that are built on leased land are generally under the control of the Buildings Department and the Buildings Ordinance and Building Regulations. But those projects that are built on government land are approved and managed by the relevant government managing department. Now, the tramway, since it was built in 1888, has always been on government land, and the Peak Tram is allowed to operate on that government land through an operating right, which is granted every few years on application. But if we go back to 2012, when the project was first promulgated, we made an application to Transport Department to extend the right to operate the Peak Tram. In 2013, government discovered that the ordinance, the law as it existed, didn't give them the power to grant this operating right. So 2 years were used to amend the Peak Tram ordinance to allow this. And at the same time, as I mentioned at the top of the show, the Peak Tram was more tourism than transport at this time. And so our managing department was transferred from transport to tourism. And in 2016, having got the operating right secured, and the operating right is important because if we don't guarantee to have the operating right, then we can't justify the expenditure in our business case because we might not be able to make a return on investment if we have too short a time to operate it. So anyway, in 2016, the project started in earnest, and that's when I came on board. Now, early on in the project, we'd set out a few options about how to get the project done. And given that all of the existing infrastructure, the ropes, the rails, the haulage equipment, the cars and everything needed to be removed, a total shutdown of the service is inevitable at some point. The big question was, should we shut down once and complete the whole project, rip everything out, put it back together? And when we ran the numbers on this option, the overriding concern was the loss of business over such an extended period. And in particular, if the end date seemed to run out. People could also then get used to the fact that the Peak Tram wasn't running, and it could be hard to restart demand after more than a year out of service. So our other option was to move the stopping position of the Lower Terminus uphill to its final location, thereby, as I say, creating that contained site for the building of most of the new Lower Terminus and allowing the service to restart. And this was the option that we chose, and this was the option that we programmed. 2 short periods of service suspension, and sandwiched in between them is a period of full operation, but from a temporary platform uphill of the new Lower Terminus. Now, I have to say, with the benefit of hindsight and some of the events that I'm just about to describe, this has proven to be absolutely 100% the correct approach. Now, this is a unique project, and I've got to say that that was a big part of the attraction for me whilst I was being hired. I recall very clearly one question from my interview when my boss asked, "What is the biggest risk to the project?" And I gave him a one-word answer, and the one-word answer was government. Now, in Hong Kong, we build some remarkable things, and we are very good at delivering very many complex projects and infrastructure. But the Peak Tram hadn't been upgraded since the 1980s. And whilst it was entirely likely that nobody really knew how to approve the project, so whilst we made our first technical submission to government in late 2016, it wasn't until late 2017 that the land boundaries were amended to grant the additional land shown on the screen now that the project needed. But rather than just tack on those 2 extra bits of land, government changed the whole of the site of the Lower Terminus, shown here in red, into a leased area. And with that, as I said, the statutory control changes. Anything we build within this land has to go through the full building construction regulation process. And because we'd gone for a 2-step approach, we had to do it twice, both for the temporary platform and the permanent platform. Now, in global terms, this pushed our likely completion date out from mid-2020 to late 2021. But still, we now had a program, albeit extended, as even our temporary platform needs to go through the full statutory process. Once we'd sorted all that out, and we'd tendered and we'd awarded the contracts, by November 2018, we started the works. Tram system supplier was designing, and the main building contractor, the main civil contractor were on site and mobilized, and progress was good. We then suspended in April 2019, and we were closed down for the 3 months that we expected to be closed down, when then we reopened on the temporary platform after only 3 and a little bit months. And that was fantastic. And I think we did very well with that. But I would be interested to hear your thoughts on how you embed risk management into the project team's thinking. Now, in my experience, many see project management and risk management in particular as something the risk manager does, rather than being an integral part of their day-to-day duties. And it was quite difficult to get people to do a comprehensive risk assessment on this project. But we did it anyway, and what we tried to do was to break it down into task-based management by giving all of the mitigation actions to those best placed to take them. And we continued through into 2020, mitigating, as I say, all imaginable risks. And then the defining black swan event of 2020. Who could have foreseen that? Now, you can do risk management with the best will in the world. I defy anyone to have foreseen that. And so here we are, 2 years later, still managing the fallout from that event, whilst making contingency plans that change regularly. Global supply chains stay strained. I mean, we're fortunate that we were able to ship our trams and our haulage equipment from Europe before this summer. But other materials and components haven't arrived on time. When work from home started, we were in a fantastic position because all of our documentation was online on SharePoint, and all of our consultants and contractors had access to that system. So we had slightly less downtime due to work from home, but not everybody was so well prepared for that. But we've also had local problems. We've had power supply issues across the border in China, which have led to some factories on 3-day working, which has slowed factory production. We've had aggregate and cement shortages that have restricted concrete availability in Hong Kong. And now, right now, travel restrictions are really starting to bite again. We've actually installed all of the new mechanical and electrical equipment, and we're starting to cable it up, and we're hoping to power it up in December. But with the travel restrictions, that could be affected now quite seriously, and that would affect our testing and commissioning phase very severely. But possibly, and because the project's been going on for so long and has been hit by so many setbacks, probably the most significant aspect right now is fatigue. I think our team are tired. I think they've had enough of travel restrictions, delays, problems, and other things. And I think project fatigue has set in for some, if not all. And for me, as the project director, that's one of the most difficult tasks currently at the moment, is to try and manage all those soft aspects as well. So when I held my promise and Jim asked me to come up with a title for tonight, the first thing that came to my mind was that the project as a whole is an uphill struggle, but that is the nature of projects, isn't it? That's it on presentation time. I'm happy to take questions if anybody has any.
Excellent. Thank you, Mark. Thank you for sharing your knowledge on this project. And yeah, as you say, the title kind of reflects everything that's going on. We've definitely had some nice comments come through to say thank you for your time. There's a question here. Are there any other tram projects globally that you're able to learn from? For example, I know there's a tram system in Christchurch in New Zealand.
Tram systems are different. The key about a funicular is, the reason a funicular is necessary is because of the slope of the terrain that the funicular is going to go up. It is actually pulled by a rope as opposed to being friction on tracks. So what we did do was we looked at, there is one other funicular in Hong Kong, which is the Ocean Express, which runs through Ocean Park, which is one of the theme parks in Hong Kong. We do have some information exchange with them. Theirs is a fairly straight line track within a purpose-built tunnel, so they don't have a lot of the variations in angle and slope that we have. So we took most of our lead actually from Switzerland, where the manufacturers are based, and went on some wonderful and wacky funiculars to understand more about what was possible before we set off designing what we were going to do.
Excellent. Thank you, Mark. How wide or varied was your project team? How many people were working on it?
Well, hundreds. I have a consultant for absolutely everything, as you can imagine. We have heritage consultants and environmental consultants and acoustic consultants over and above the mainstream architects, engineers, and QSs. But we also have an artwork consultant, so we can manage the production of the art that we're talking about. We have AV and experience consultants to help design some of the exhibits in there. And we probably have 30 different consultant companies and a handful of contracting companies all contributing.
Excellent. Thank you, Mark. And hopefully you can see the nice comments coming through, and I encourage everyone to let us know what your key takeaways are. I can see someone's asked, what is the estimated completion date for the project?
Yes. Right now, we're scheduled for first quarter 22. But as I say, the travel plans and the travel restrictions. I mean, even this week, some of the guys who were going to fly here from Switzerland had the flights cancelled because Swissair wasn't flying into Hong Kong. It's a real movable feast at the moment. So we do what we can do, and we're aiming for first quarter 22.
Excellent. Thank you, Mark. Josephine has said, really interesting presentation. I would agree it will be one of the most difficult projects. Jimmy has asked, what is an EPC project?
An EPC project, and that's probably one that Jim might be better talking about, because I think Jim will do more of those for CLP than for the Peak Tram. It's more of a US term than a European term for turnkey, isn't it?
Yeah, that's correct. Yeah. Engineering, procurement, and construction lump sum contract. I assume this contract here would be a multi-contract approach, equipment supply, consultancy.
Yeah, we have a whole load of fairly traditional building design consultancies to do the terminus at both ends and the intermediate stations. Our tram system supply contract is probably what you might call an EPC. They do the engineering, they do the manufacture, the production, the installation, and the testing and commissioning. So that's probably the closest you're going to get on this.
Excellent. Thank you, Mark, and thank you, Jim. I've had a question. It looks like it's from a local who said, after the upgrade, Kennedy Road stop will be very close to the lower terminal. Will this stop be cancelled when the project finishes?
It is very close. You're right. It's not our intention to stop using Kennedy Road Station. During busy times, we may bypass some of the intermediate stations because the trams will be full. But we've just actually raised the level of Kennedy Road Station so that it can be at the same level as the tramcar floors. And we've installed all the equipment there. So yeah, it's our intention to continue using it.
Excellent. Thank you, Mark. It looks like we've covered all the questions that have come through. I must admit, I was making notes to ping you with some questions, and then you answered it in the next couple of slides about what did I ask you about? The access into the site, etc. And you've certainly covered those. So thank you for that. Jim, if you're still with us, would you like to ask any additional questions or bring today's event to a close?
Yeah, well, first off, I'd like to really thank Mark for taking the time to show us this very interesting project. This is, if you've ever make it to Hong Kong, it's one for sure to go and make a trip up to the Peak, make one in the evening, make one in the morning. It's really quite a thing to experience. Also like to thank Mark for his dedication on the project and carrying through on this, as well as his previous service to APM. We really appreciate that. Encourage everybody, visit us on our website, visit us on the APM website, follow us on there, and you'll see our future events that come up. And I think possibly may have one in January, so stay tuned.